In this video, we're gonna continue finding the limit of the sequence. So you see in this example 7, you have the sequence n plus 1, no, n over n plus 1 to the 2n. And you see that you like to find limit n go to infinity of n over n plus 1 to the 2n. And if you are taking n go to infinity, you see the limit of the thing that sits inside parentheses. Here is turned out to be 1, and here is going to turn out to be 1 to infinity. So this one is going to be indeterminate form that we had last semester. We're going to use L'Hopital rule in order to find this limit. So we have limit n go to infinity of n over n plus 1 to the 2n. We're gonna try to write this thing as e. Okay, so it's gonna turn out to be e, and you have 2n log of n over n plus 1. Okay, so it's gonna be like last semester, you have 2n and you're gonna move 2n down. So it's gonna be e log 2n plus 1 like this. And you are having, okay, to find the limit of the exponent here. Okay, so it's gonna be e to this limit. Okay, so it's gonna be e to the limit of 2n times log n over n plus 1. And we're gonna try to find this limit. So it's gonna be e, and it's gonna be this number that we like to find. So it's gonna be limit n go to infinity. Okay, so you have 2n log n over n plus 1, and you're gonna find this limit by just you're gonna write this one as limit n go to infinity of log n over n plus 1, and you have 1 over 2n by flipping the blue guy down. Okay, so you flip this one and it's gonna turn out to be 1 over 2n on the bottom like this. And you see that if you are taking n go to infinity, this would give you log 1. And on the bottom, it's gonna turn out to be 0. And this one becomes 0 over 0. And it's turned out to be just L'Hopital indeterminate form 0 over 0. So it's going to be 0 over 0, and you would just use L'Hopital. Okay, so you're going to differentiate. Before we differentiate this one, so we know that it's going to be, you have log n over n plus 1. So this one will become log n subtract by log n plus 1. Okay, so you have log n subtract log n plus 1. So you would get limit n go to infinity. Okay, so you get log n. Okay, so it's going to be log n minus log n plus 1, and everything is going to be over 1 over 2n. And you're gonna differentiate. So you differentiate the top is gonna be dip log n is gonna be 1 over n. Dip log n plus 1 is gonna be 1 over n plus 1. And you differentiate 1 over 2n, so it's gonna be 1 over 2. And you differentiate 1 over n, it's gonna be negative 1 over n squared. Okay, so this one will be just applying L'Hopital, and the variable that you are using turn out to be n. And this will become limit n go to infinity. Okay, and the top one turn out to be n plus 1 minus n. The bottom one is n over n plus 1. Okay, and you're gonna have negative 1 over 2, 1 over n squared. So the key thing is going to turn out to be simplifying the term that you have here. So this one will be n squared over n plus 1, okay? And you're going to flip negative 2 up also, okay? So you're going to flip negative 2n squared. And so you see that this guy will be okay, so this guy will be just, you have negative 2 and n squared, so it's going to be negative 2n squared over n squared 1 plus 1 over n, and you're gonna have n squared get rid of each other, so you get n go to infinity, this one become 0. So the whole number that you get here is gonna be negative 2. Okay, so you get negative 2 to be this limit. And when you have negative 2 to be this limit, you're gonna plug this number here. So it's gonna be e to the negative 2. Okay, and you're gonna just have the limit that you're looking for turn out to be e to the negative 2, and your sequence is convergent. Okay, so this one will be your solution here. The next one, you have sine n cos n over square the fourth root of n. So for this one, when you have limit n go to infinity, of sine n cosine n over the fourth root of n. So you see that the bottom turned out to be infinity and the top turned out to be sine infinity, cosine infinity. And this guy, we don't know the value, okay? We don't know the value of sine infinity, cos infinity. So the thing that we're gonna try to use in this case is gonna be, we're gonna try to get rid of cos and sine, okay? And if you recall, we have 2 sine n cosine n. This identity will be equal to cosine of, no, not cosine of, it's going to turn out to be sine of 2n. Okay, so it's going to turn out to be sine of 2n. So you're gonna have sine n cosine n is sine 2n over 2. Okay, so it's become sine 2n over 2. So this one is gonna turn out to be this pink term. Okay, and so you're gonna try to find, okay, so we have sine 2n over 2 and root n, the fourth root of n. Okay, so it's going to be sine 2n over 2 times the fourth root of n on the bottom. So this one is the function that we would like to find the limit n go to infinity. Okay, so we shall use Squeeze theorem. Okay, so if we use Squeeze theorem, as you see before, okay, so you have sine 2n must lie between negative 1 and 1. Okay, so you have sine 2n lies between negative 1 and 1. So you're going to multiply the whole thing by 2 the fourth root of n to the fourth root of n to the fourth root of n. Okay, so this is your sequence that you like to find. Let me just write an Okay, so you have a line between these two terms. So you're gonna compute limit n go to infinity of negative 2 the fourth root of n. So it's gonna become 0. And you have limit n go to infinity 1 over 2 the fourth root of n. And this guy is also equal to 0. So you have the limit of the yellow guy equal to 0. The limit of the blue guy also equal to 0. So it will imply that the limit of the middle guy turn out to be equal to 0. Okay, so that will be just the squeeze theorem. Okay, so we by squeeze theorem, the limit of the middle guy, so it's going to be psi 2n over the fourth root of n, turn out to be equal to 0. Okay, so that will be just use the squeeze theorem. Okay, so that will be the solution for this example. So you see that the thing that we use here is we use the identity psi 2n. It's going to be 2 sine n cos n and allow us to change sine n cos n in terms of psi 2n, and that will allow you to apply this identity. The next one, okay, let me do number 10 first because it's sine cosine. So for this one, the thing that you see is going to be cos square. So you would feel that you're going to use like a squeeze theorem. However, be careful a little bit for cos square. Okay, so for cos square n, we know that everything square turn out to be positive. Okay, so everything square turn out to be positive, and you're gonna have it's gonna be less than 1 square. Okay, so it's gonna be cos square will be less than or equal to 1 square. It's turned out to be 1, and you see that you can just write this one by dividing 3 to the n. Okay, so this would allow you, okay, so this would allow you to find, okay, so I forgot that we need to raise this guy to the n also. So you raise this guy to the n, you raise this guy to the n, and you raise this guy to the n. Okay, so in this form, so you see that this would give you the middle guy. Okay, so this would give you the middle guy. So you have cos square n over 3 to the n. Okay, and you would get 1 over 3 to the n, and you would get 0. Okay, and you know that limit n go to infinity of 0 turn out to be 0, and you know that limit n go to infinity of 1 over 3 to the n, so it's 1 over infinity, so it's become also 0. So you have the limit of the yellow guy equal to 0, limit of the pink guy also equal to 0. So you're gonna have the limit of the middle guy that you're looking for turn out to be 0 as well. So it's gonna be cos square n over 3 and everything to the n turn out to be equal to 0 by Squeeze theorem. Okay, so that's how we write down the solution correctly. Okay, so the next one is going to be the sequence that involve n factorial. Okay, so for n factorial over n to the n, okay, so for n factorial over n to the n, so let us recall about the definition of factorial a little bit. So when you have n factorial, it means that you have 1 times 2 times 3 up until n. Okay, so it's going to be 1 times 2 times 3 times up until n. And you're gonna have n factorial over n to the n. So it's going to be 1 times 2 times 3 up until n over n to the n. So it's going to be over n times n times n times n. Okay, so for this one, it's going to be 1 over n, 2 over n, 3 over n. Okay, and you can write n minus 1 over n. Okay, and you have n over n. So you have n factorial over n to the n turn out to be 1 over n, 2 over n, 3 over n until you have n over n. Okay, so that's going to be this calculation. Okay, and you see that from here, if you want to squeeze theorem, you want to use squeeze theorem, the thing that you must notice turn out to be for n. Okay, so for n more than 1, okay, so if you have n more than 1, this term that I'm gonna highlight blue color. So if I ask you, what is the value of the thing that I highlighted blue color here, you're gonna see that this one is gonna be 2 over n, 3 over n, and so on. So if you have n large, okay, for n large, for n large. So when you have n large, this guy will become smaller than 1, will become smaller than 1, and will become smaller than 1, okay? So the whole thing here, when you product them, it's gonna turn out to be smaller than 1. Let me explain this guy again. So the thing that I'd like you to notice will be for n large. Why do we care when n is large? Because we are caring for n go to infinity. Okay, so we would like to study the behavior of the sequence when n large. So it's going to be mean that we're going to have n go to infinity. And when n go to infinity, the thing that you notice turn out to be 2 over n, 3 over n, and n minus 1 over n turn out to be less than 1. Okay, so it means that the blue guy here will turn out to be less than 1. Okay, so the thing that I would like, it's gonna be n factorial over n to the n will be less than, okay, so the thing that so y turn out to be 1 over n, okay, and n over n here turn out to be equal to 1, so I'm gonna say multiply by something smaller than 1 times 1, okay, so it's gonna be 3 terms, okay. So it's going to be 1 over n times the thing that is smaller than 1, and n over n is 1. Okay, so you see according to the color. So the whole thing here, okay, so the whole thing here will become, okay, so the whole thing here will become smaller than 1 over n. Okay, so the whole thing here will become something smaller than 1 over n. And you have n factorial over n to the n. This guy always positive, okay, so it's positive. So when you have something positive, it's gonna turn out to be more than 0. So you see that we'll be able to have n factorial over n to the n lies between 1 over n and 0. And if you consider limit n go to infinity of 0, it's going to turn out to be 0. And you have limit n go to infinity of 1 over n. Okay, the limit of the green guy turn out to be equal to 0 as well. So you have limit n go to infinity of the middle guy, which is n factorial n to the n. This guy will become 0. Okay, so that's all. Okay, so that will be just the limit that you have. Okay, I will do one more example on something like this, and I'm gonna go back to answer the question if you still not quite fully understand for this one during the recitation. Okay, I know this one is a little bit difficult to understand. Okay, for number 11, you see that we are dealing with n fact again, and it's gonna turn out to be n factorial over 2 to the n, and it's gonna be 2 to the n over n factorial. Okay, so let's do the second one first. So you have 2 to the n over n factorial. This guy will become 2 times 2 times 2. Okay, so you see that you have many terms of involving 2. Okay, and on the bottom again it's going to be 1 times 2 times 3. Okay, so it's going to be up until n minus 1, and you have n. Okay, so it's going to be 2 times 2 times 4. And you see that this term, okay, so let me circle term by term here. So the first term is 2 over 1. This guy is 2 over 2, okay? So you have 2 over 1 equal to 2, 2 over 2 equal to 1. And for this blue term, 2 over 3, 2 over n, and the term that's sitting in the middle. This guy, if you consider this guy is smaller than 1, this guy is smaller than 1 when n large. Okay, so they are smaller than 1 when n large. Okay, and you see that the whole thing will become smaller than 1. Okay, so that will be the blue guy. Okay, and the yellow guy stay 2 over n. Okay, so the yellow guy stay 2 over n. So we're gonna combine everything together. How could we do that? It's gonna be this guy multiplied with the yellow guy, okay, and multiply with the blue guy, okay. So this one will become 2 times 1 times something smaller than 1 and 2 over n. Okay, so it's going to be 2 times 1 times something smaller than 1 and 2 over n. And for this one, you see that it's going to be, okay, so you see that you can have 2 to the n over n factorial less than 4 over n. Okay, so this one will be just 4 over n. So it's going to be smaller than 4 over n. And you have this one is positive. So it will be more than 0. Okay, so it's going to turn out to be positive. And you know that limit n go to infinity of 0 equal to 0, and limit n go to infinity of 4 over n turn out to be 0 as well. So you're gonna have limit n go to infinity of 2 to the n over n factorial will become 0 by Squeeze theorem. Okay, so it's gonna be that kinds of limit that we looking for. Okay, so that is gonna be this limit that we like to find. However, we're gonna have another problem. What will happen if we like to find the limit n go to infinity of n factorial over 2 to the n instead? Okay, so what will happen for the next term? So you have, okay, so let me use this space. So you have n factorial over 2 to the n. It's going to turn out to be reciprocal of the previous one. So it's going to be 1 times 2 times 3 and so on, so forth. And it's going to be n minus 1 times n. And everything will be over 2, 2, 2, okay? And it's going to be 2 and 2. So you see that the first term turned out to be 1/2. Okay, so the first term turned out to be 1/2 and 2 over 2, they cancel each other. And you have 3 over 2. Okay, so let me highlight this term. So you have 3 over 2. You have n minus 1 over 2. Okay, so you have n minus 1 over 2 like this. And this guy turned out to be more than 1. Okay, so this guy turned out to be more than 1, and this guy turned out to be more than 1. So you see that the pink one in the middle turned out to be more than 1. And the whole thing will become, okay, so we become the product between this guy, so it will become more than 1. So it means that you're gonna have 1 over 2 times n over 2, which is the yellow guy. Okay, so you have n over 2, which is the yellow guy, and you have something in the middle more than 1. So when you multiply them together, you would get more than n over 4. Okay, it's more than because the pink guy and n over 4 come from the yellow one, okay, come from the yellow one, multiply with 1/2, okay, n over 2 multiply 1 over 2, so it's going to become n over 4, okay, so this one will be just the thing that you see, okay, so that is this calculation. And so we compute, okay, and you can take limit both sides. So if you would like to have limit n go to infinity, so it's going to become more than limit n go to infinity of n over 4, and limit n go to infinity of n over 4 turn out to become infinity. And you're gonna see that this limit is more than infinity. Okay, so this limit is more than infinity. So you're gonna say that limit n go to infinity of n fact over 2 to the n will be infinity. And you have the sequence n fact over 2 to the n turn out to be diversion. Okay, so it's gonna be just that. Okay, so that will be just the last example for conversion and diversion. You see that we apply many techniques and you can see or you can try. Okay, so let me give you one example to try on your own. If you have, okay, it's gonna be e to the n over n factorial. Okay, so if e to the n over n factorial, so this one is convergent. Please show, okay, so please show that this guy is convergent. Okay, I will give you the solution during the recitation. Okay, The last thing that we gonna talk about sequence turn out to be about increasing and decreasing. So you have the sequence is called increasing when you have the next term is higher than the previous term. So you have A1 less than A2, A3 greater than A2. Let me define that way. So increasing means the term of the sequence, the next term of the sequence turn out to be higher than the previous term. So you have A2 more than A1, A3 more than A2, A4 more than A3, and so on. This one is called the increasing sequence. And the sequence is decreasing turn out to be opposite. So it means that the previous term is more than the next term. So you have A1 more than A2, A2 more than A3, A3 more than A4, and so on. Okay, and when you have the sequence increasing or decreasing, it's going to turn out to be called also monotonic. Monotonic is going to be either increasing or decreasing. The way to check decreasing and increasing turn out to be just direct comparison. Okay, so it's going to be the way that we like to test for increasing, decreasing. It's going to be just using basic identity. Okay, so I'm going to just say use basic inequality. For example, you have n square is increasing. N square is increasing due to, okay, so we know n smaller than n plus 1, okay, and you're gonna just raise to square both sides. So you would just get n square smaller than n plus 1 square, okay? So you have an smaller than an plus 1. So it means that the next term is more than the previous term. So we have increasing. Okay. The next one, you have 2 over n. 2 over n is going to be same thing. So we know n smaller than n plus 1. And you flip this one, so you have 1 over n plus 1. So when you flip the inequality, so it's going to become more than, okay? So 1 over n, the reciprocal, is going to turn out to be more than 1 over n plus 1, okay? And you're going to just multiply the whole thing by 2. So you would get 2 over n more than 2 over n plus 1. So you have an more than an plus 1, and this will say that the sequence is decreasing. Okay, so it is decreasing. For the next one, you see that it's gonna be, we not be able to use basic identity or basic inequality, okay? So this one, I'm gonna say that it is hard to use basic inequality because you see, e to the n plus 1 more than e to the n. Okay, so this one we know. However, you have 1 over n plus 1 more than, it's turned out to be less than 1 over n. So you not be able to combine both of these together in order to conclude increasing or decreasing of the sequence. Okay, so you see that this one are not matched to each other. So we not be able to show that it's going to turn out to be increasing, decreasing by using just the basic inequality. Similarly, for this guy, n over n squared plus 1, this guy is decreasing. Okay, so this guy is decreasing, and you see that we cannot see this guy right away from the basic inequality. So the thing that we're gonna use is gonna be, we're gonna use derivative. Okay, so I'm gonna just say that. Okay, so it has to use basic inequality. Let me just put, so we shall find its derivative. Okay, so we shall find its derivative. Okay, so in this case, you have fx equal to e to the x over x. I change this guy into x because we normally memorize the formula in terms of x. If you differentiate in terms of n, it's going to make your brain a little bit hard to find the derivative. Okay, so try to change this one into x, and you're going to see that this one is going to be a lot easier in order to find f prime. Okay, so we familiar with x more than n. So you have f prime x is going to be the bottom derivative of the top minus the top derivative of the bottom over the bottom square. Okay, and you see that this will give you x minus 1 e to the x over x. Okay, and you have x more than or equal to 1. Okay, I know that x is more than or equal to 1 because you gonna just have n more than or equal to 1. Okay, so this one before is n. Okay, we change everything to x. So when you have n, it's turned out to be n greater than or equal to 1. So in this case, you're gonna have x greater than or equal to 1. So in this function, it's gonna be only for x greater than or equal to 1. And you see that when x greater than or equal to 1, this term become positive. Okay, I'm gonna say that this guy is positive. Okay, so this guy is positive and this guy is also positive. And e to the x is also positive. Okay, so you have e to the x is also positive. Okay, so in this case, you're gonna have f prime turn out to be positive. Okay, so you have f prime x is positive. Okay, so you have f prime x is positive. So you have an is increasing. Okay, so you have e to the n over n is decreasing. Okay, so for number 4, I will let you work on this one first. So for this one, you're gonna have fx equal to x over x squared plus 1, and you have x greater than or equal to 1. Okay, and you're gonna find f prime x. And conclude that f prime x is negative. Okay, and that will allow you to conclude that your sequence is decreasing. So let me conclude this one. Okay, so to show increasing or decreasing, okay, we have two ways to show. Okay, so it's gonna be, we may, okay, so use n plus 1 greater than n and divide by basics inequality. Okay, so that the first thing that we can use. And the second way is going to be, okay, and the second way is going to be you differentiate. Okay, f prime x, okay, f prime x positive is going to be increasing. Okay, and this one is going to be only for x more than 1. Okay, so it's going to be this guy, and you have x greater than or equal to 1, and you have f prime x negative x more than or equal to 1, it will give you decreasing. Okay, so that will be the thing that you use in order to determine increasing or decreasing of sequences. Okay, so let me highlight this guy. Okay, so you can use basic inequality, or you just use derivative for showing increasing or decreasing. Okay, so please finish this one. Okay, so please try to finish this one on your own to see the derivative of this function, and I will give you the solution during the recitation. Okay. The last thing that we're gonna have is gonna be, we're gonna try to find the limit, or we're gonna try to determine conversion or diversion of alternating sequence. So this one is called alternating sequence. Alternating sequence will involve the term -1 to the n. Okay, so you see that we are having -1 to the n, and it's going to be -1 to the n multiplied with the term of the sequence. So this one is going to be -1 to the n, and you have time 2 over 2n over 2n plus 1. Okay, so that's the first sequence. The second sequence can be written as -1 to the n, 1 over 2n plus 1. And the third one is going to be -1 to the n over 2n plus 1. Okay. So you see that for -1 to the n for alternating sequence like this, the thing that you see is gonna, when you plot the graph for this sequence, so when you plot the graph for this sequence, it will be alternate up and down, up and down. So you have something down here, something up here, something down here, something up here, something down here, something up here. Okay, so you see that if you plot, okay, when n equal to 1, n equal to 2, n equal to 3, it's going to be scattering. Okay, so it's going to turn out to be scattering, and it's going to turn out to be uncontrollable. And it's going to be some gap. The gap here, okay, so the gap that we have here turn out to be equal to the limit n go to infinity of an. Okay, so this term is my an. Okay, so it's going to be limit n go to infinity of an. And we need the gap to be 0. Okay, so we need the gap to be equal to 0. So in this case, this one turned out to be, you have the gap equal to an. So we have limit n go to infinity of -1 to the n an, and -1 to the n is the purple guy here. Okay, so you have this one equal to 0 if and only if the limit n go to infinity of an, okay, so which turn out to be the gap is equal to 0. Okay, so when you have this limit, the behavior turn out to be the behavior of the gap, and you need the limit exist. The limit exist mean that the gap becomes 0, and the gap becomes 0 look like something like this. So it's going to be somewhere here. Okay, so it's going to turn out to be somewhere here, somewhere up here, somewhere out here, somewhere this here, and this here. Okay, so you see that it's gonna be this one, this one, this one, this one, this one. And you see that if you have the gap very small, closing to 0, it's gonna turn out to be limit equal to 0. However, if the limit n go to infinity, and in this case not equal to 0, okay, so if you have limit n go to infinity of an not equal to 0, it's gonna imply that this limit turn out to be does not exist. Okay, so it's gonna be doesn't exist. Okay, so this will be an important conclusion. So this is what we have here. So the sequence converges to 0, okay, if and only if the limit of the gap, so it's going to be limit n go to infinity of an turn out to be equal to 0. So let's try to find each limit here. So you're going to have an in each case. Okay, so this one is going to be an. Okay, so for the first one, okay, so let me write down the first, the second, and the third a little bit. So this one is your first, your second, and your third. Okay, so for the first guy, you have limit n go to infinity of 2n over 2n plus 1. This guy will have limit, okay, so it's going to be 2n over 2n, and you have 1 plus 1 over 2n. So you have n, okay, and you have 2 plus 1 over n, and so it's going to become 2 over 2 equal to 1. Okay, so you have the limit of your an, okay, turn out to be 1, not equal to 0. Okay, so the conclusion for the first one will be limit n go to infinity of that guy. So it's going to be -1 to the n, 2n over 2n plus 1 turn out to be does not exist. Okay, so that will be the first one. The second one, okay, so I need some space. Okay, so for the second one, you need to check For the second one, you need to check limit n go to infinity of 1 over 2n plus 1, and this one become 0 automatically. So you're gonna say that limit n go to infinity of negative 1 to the n, 1 over 2n plus 1 must be 0. Okay, so that's the second one. And the third one, you like to find limit n go to infinity of n over 2n plus 1. So this guy, okay, same thing, it's going to become n over n2 plus 1 over n. And this guy is 1/2, okay? And 1/2 not good enough, so it's not equal to 0. So we're gonna conclude the same thing, that limit n go to infinity of negative 1 to the n, n over 2n plus 1 also does not exist. Okay, so we have the limit does not exist when the limit does not equal to 0. Okay, so the conclusion here turned out to be we have the alternating sequence. Okay, so this one is going to be alternating sequence. Okay, so the alternating sequence turned out to be convert to 0 if and only if limit n go to infinity of an equal to 0, and the alternating sequence an is diversion. It's going to mean that you have the limit n go to infinity of an does not equal to 0. Okay, so this one is also important. Okay, so you're gonna have to do this one on your own. Okay, so do this example 11. So you see that you have negative 1 to the n. Okay, so you have negative 1 to the n for both of this guy, and you need to determine whether limit n go to infinity of an turn out to be equal to 0 or not. Okay, and I'm gonna conclude this one during the recitation how to find the limit. Okay, so that should be all for this lecture. Okay, and it's gonna be about the sequences